Hi guys, so today we're going to go over linear factorization, which sounds more complicated than it actually is. I have included some algebra problems just to kind of give you a refresher. Um, so remember x squared minus 100. Yes, you can rewrite it as x squared plus 0x minus 100 and factor it the same way we've been going over in quadratic functions. However, the most difficult part about factoring a difference of squares is being able to recognize it. So if you recognize that this is a difference of squares, then there is a shortcut to factoring it. So keep in mind difference because it has to have a subtraction sign. So difference of perfect squares. So it does have a subtraction sign, and I am able to take the square root of each one of them perfectly. I'm emphasizing the difference because you're not square rooting the negative with the 100. So difference has already been compensated for, that it's a minus sign because it is a difference of perfect squares. So the shortcut for this is one parentheses will say plus, one parentheses will say minus, and again, they're perfect squares, so I should be able to take the square root of each one of them perfectly. The square root of x squared is just x, and the square root of 100 is 10. So just kind of popped into my head, why is the square root of x squared x? Because the square root is nothing more than a power of 1/2. Just like a cube root is nothing more than a power of 1/3. Fourth root is nothing more than a power of 1/4. So when we have a power to a power, we multiply it. And 2 times 1/2 is just 1, x to the first power. So just popped into my head. But you can check your factoring by FOILing or distributing, and it will bring you right back to x squared minus 100. So moving on, just a quick little algebra review still. The first step to any factoring problem is technically always looking for the GCF. So most of the time we overlook that because there's not a GCF, just like in problem number 1, but you should always check. So case in point here, for number 2, these two do have a GCF. They have x squared in common. So if I factor x squared out, meaning I divide it out of each one of these terms, x to the fourth divided by x squared. If you remember your properties of rational exponents, then whenever we divide the like basis, we end up subtracting the exponents, top minus bottom. So that would give me x squared. And you can always kind of see it as there's 4x's in the numerator. I don't know why all my sidebars over here, but it's happening. And x squared meaning there's 2 down here. So, they divide out, leaving you with x squared. And then same deal here, factoring it out means dividing it out. So if I take negative 100x squared and I divide x squared out, negative 100x squared and I divide x squared out, the x squared will, the x squared will divide out, leaving me with minus 100. So I'm going to bring down the GCF, and if I look inside of that parentheses, that happens to be not only a difference of perfect squares, but the same difference of perfect squares we already factored. So we are going to just factor it. So linear factorization, you're factoring it down until it can't be factored anymore. So why is this relevant? Well, for number 3 and 4, they're not exactly a difference of perfect squares. So what happens here when I need to factor it? So you do still have 2 parentheses. One is still plus and one is still minus. Just when I take the square root of each one of them, the square root of x squared is x. Keep in mind, since this is no longer a difference, now it's like I'm taking the square root of negative 100, which is technically 10i. So bringing back an algebra review, let me bring back my sidebar here. To take a negative out of a square root, you would use the imaginary number I, leaving you with positive square root of 100. And the square root of 100 is 10. But it's not just 10, bring down the I, but positive and negative. So that's where the plus and minus comes from. So how do I know this is actually true? Well, this is the linear factorization, but I'm going to check it. So um, I'm going to bring it here because I'm out of room. So again, to check any of your factoring, you can always use FOIL. So x plus 10i, x minus 10i. And you can use FOIL, which is first, outer, inner, last, but a little fun fact about conjugates. Remember, conjugates are the same exact term, opposite operation. You can use a shortcut called Florida, meaning I don't need to do outer and inner if I don't want to because they're just going to add up to be 0. Anytime you multiply conjugates, they're going to add up to be 0 for outer and inner. If you forget, it's fine. You could use FOIL, just kind of, a fun fact there. So I'm going to use Florida first and last. X times x is x squared. And last, 10 times negative 10 is negative 100, and I times I is I squared. Bringing back your algebra review, because it's just not going anywhere, remember that I squared does equal to a value. I squared equals negative 1. So I know I'm going a little all over the place here, but a lot of algebra stuff is just popping up into my head. So remember the square root of negative 1 equals to I. That's how we got I out of square root of negative 100. The square root of negative 1 equals to I. So what happens if I square both sides? The square and the square root get rid of each other, and that leaves me with negative 1 equals I squared, which is the same thing I wrote here. So just why does I squared equal negative 1? I felt the need to write the proof out. I don't know why, but bringing right back down here to check the work, I squared does equal to negative 1. So PEMDAS tells us to multiply. Negative 100 times negative 1 gives me positive 100. And I'm going to bring that x squared down. And if I look, it brings me right back up to the problem I had in number 3. So what happens when it's not a difference of squares or perfect squares? When it's a sum of perfect squares, you're going to have imaginary numbers for your second perfect square. Kind of reiterating this again, just make sure you look for the GCF in case there is any. We have x squared as the GCF for these two terms again. And that'll leave me with the parentheses x squared plus 100. So when it is a sum of perfect squares, you can use the same method. It's just the second square will always be imaginary. So one is plus, one is minus, and then 10i happens to be the same problem as before. I don't know why I did that. And then the GCF comes right down. Okay, so I hope this helps, guys. Please let me know if you have any questions.